decades, the image of prehistoric Europeans in our collective imagination was painted pale, light-skinned, blue-eyed, blonde. It was an image that carried a quiet assumption that when modern humans migrated into Europe around 45,000 years ago, evolution would have quickly sculpted their pigmentation to suit the colder, darker climates. After all, sunlight fuels the synthesis of vitamin D, and paler skin is more efficient at soaking it up through the UV-starved winters of the north. But science, with its habit of defying expectations, has rewritten that narrative. Ancient DNA, fragile threads of history preserved in teeth and bones buried beneath millennia of soil, is revealing a truth far more intricate and far more fascinating. A sweeping study of 348 ancient genomes ranging from 1700 to 45,000 years ago has now offered us the most comprehensive glimpse yet into how pigmentation traits in Europe evolved. Not just skin, but eyes and hair too. And the takeaway is nothing short of mind-blowing. Dark skin, not pale, was the dominant trait among the early peoples of Europe. Let that sink in. According to the study, a staggering 63% of the ancient individuals studied likely had dark skin. Just 8% had pale skin. The rest, well, they fell somewhere in between, intermediate tones that painted a diverse portrait of ancient Europe far removed from our assumptions. It wasn't until as recently as 3,000 years ago, barely a blink in evolutionary terms, that light and intermediate skin tones became dominant among Europeans. For tens of thousands of years before that, the lands we now call France, Germany, the British Isles, and Scandinavia were likely populated by people with much darker complexions than most of their modern descendants. This challenges not only scientific assumptions, but also deep-seated cultural narratives. And it sparks a new appreciation for the complexity of human adaptation. So, what changed, and why so late? For years, the prevailing theory held that skin lightened quickly after humans left Africa and ventured into the northern latitudes, driven by natural selection. Less ultraviolet light means less vitamin D production. Pale skin, being more translucent to UV rays, would help prevent rickets and other health issues linked to vitamin D deficiency. Simple, elegant, logical. But evolution rarely reads our textbooks. One key problem with this hypothesis lies in diet. Paleolithic hunter-gatherers, our distant ancestors, weren't exactly relying on agriculture. They hunted, they foraged, they ate wild meat and fatty fish, often rich in vitamin D. Even in the gloom of northern winters, their nutrition may have been more than compensated for any drop in sunlight. It wasn't until much later, when people settled into large, dense communities, adopted farming, and started eating more plant-based diets, that vitamin D deficiency could have emerged as a significant problem. That turning point came in the Bronze Age. As human society evolved, so too did the pressures on our bodies. New selective forces, diet, population density, migration, began sculpting our genes in different directions, and skin tone, it seems, was caught up in that transformation. But diet alone doesn't tell the full story. Evolution is rarely about one factor. It's a tangled web of pressures. Natural selection, yes, but also sexual selection, social signaling, interbreeding, and the unpredictable forces of chance and war.
Holding here this wonderful reconstructed head of Cheddar Man, and I've been studying the skeleton of Cheddar Man for some 40 years or so.
Consider the Cheddar Man, an ancient Briton who lived some 10,000 years ago, whose DNA was analyzed in 2018. The results shocked many. He likely had very dark skin coupled with striking blue-green eyes. A vivid reminder that modern combinations of skin, eye, and hair colors haven't always gone hand in hand. But these individual predictions have limitations. Our understanding of the genetics behind pigmentation is still evolving, and it's challenging to interpret ancient DNA using models built on modern genomes. This is where the new study shines. By pooling data from hundreds of ancient individuals, the researchers sidestep some of the uncertainties. While we may not be able to predict an individual's appearance with perfect accuracy, the broad trends across a population are much more reliable.
Buongiorno, ben alzati. Siamo 7 miliardi e mezzo di
Led by
persone.
Guido Barbugiani at the University of Ferrara, the team used statistical models to estimate pigmentation traits, skin, hair, eyes, based on the partial genomes of ancient people. And while gaps in the data made it impossible to predict all traits in all the individuals, the overall picture was clear. Dark-skinned Europeans were the norm for most of prehistory. As anthropologist Nina Jablonski of Pennsylvania State University put it, the study is enormously significant for its scope and precision. It gives us a sweeping panorama of how Europe's genetic landscape shifted, not gradually, but in bursts, tied to dramatic cultural and environmental changes. And those changes came fast and hard. With the rise of agriculture and urbanization came new pathogens, new diets, and new social structures. Populations mixed more rapidly, people moved, cultures collided, and the human genome responded. Some of the genes associated with lighter skin, like SLC24A5 and SLC45A2, began spreading rapidly across Europe, likely aided by both natural and sexual selection. Light skin may have offered reproductive advantages, not only for vitamin D, but possibly because of cultural preferences that favored lighter complexions. Perhaps fair skin became associated with elite status in some groups. Perhaps it became more attractive due to rarity. These are murky waters, but they hint at just how multifaceted human evolution really is. What's equally intriguing is the absence of these pale-skinned genes in early modern humans in Europe. It turns out they weren't inherited from Neanderthals, despite the two species interbreeding tens of thousands of years ago. The genes for light skin seems to have arisen independently among Homo sapiens and only became widespread relatively recently. Even Neanderthals, who have occupied Europe for hundreds of thousands of years, likely had varied skin tones. Some may have been pale, others darker, mirroring the diversity we see in humans today. But the idea that modern Europeans inherited their light skin directly from Neanderthals doesn't hold up under scrutiny. So, if the early Europeans were dark-skinned, what does that say about how we portray our ancestors? Art and archaeology offer few clear answers. Artistic depictions, especially from ancient civilizations, are often stylized, symbolic, or steeped in cultural conventions. Egyptian art, for instance, routinely painted men with darker skin than women, but this wasn't necessarily realism, it was symbolism, or a visual code tied to gender roles and status. We can't really rely on art to tell us the truth about pigmentation. That's where genetics comes in, filling in the gaps left by ancient brushes and chisels. And what it's showing us is more dynamic, more diverse, and more astonishing than we could have ever imagined. It tells us that human skin color, like language or clothing, is a story written by geography, climate, culture, and time. It tells us that Europe of 10,000 years ago was not pale and blue-eyed by default, but a mosaic of shades and features molded by an ever-changing world. And it reminds us, above all, that the traits we often associate with identity, skin, hair, and eyes, are fleeting footprints of adaptation, not markers of inherent difference. In this light, the human story becomes more unified, not less, more intricate, not more divided. Because evolution doesn't care about our modern ideas of race or beauty or belonging, it only cares about survival, about fertility, and about who thrives in a given environment under a particular set of pressures. 3,000 years. That's all it's been since pale skin became common in Europe. Before that, for tens of thousands of years, the continent was home to people whose pigmentation defies the old assumptions. Science has shattered the myth of timeless whiteness in Europe and replaced it with a richer, more complex truth. And now, when we look into the mirror of history, we see not just ourselves, but the shadows of all the skin tones that came before. Hey everyone, we've come to the end of the video. Were you as surprised as I was that the evolution of skin pigmentation in Europe began within 3,000 years instead of 10,000 years ago? Let me know what you think in the comment section below. Also, don't forget to like and subscribe to the channel if you found any value in this video. Thanks for watching, and until next time, see you soon!